So far, when we've described a set, we've either given roster notation, so just listed all of the elements, or else we've just given kind of a vague verbal description of what the set is, like the real numbers. We had just kind of a vague verbal description of what the real numbers are. There's another way that we can describe a set, and that's what's called set builder notation. In set builder notation, we use the same curly brackets that we did for roster notation, but instead of listing all of the elements, we have a form of a generic element followed by rules that the elements need to follow. In between them, we put this vertical bar character on your computer keyboard. That's the key in the top row to the right of P all the way to the right. It's the same key that the backslash is on a standard computer keyboard. So how do we read this set builder notation? If we have, for example, A is the set consisting of all elements of the form 2n, such that, right, we pronounce this bar as such that, n is an integer. So that means A consists of all of the numbers that we can get by taking an integer and multiplying it by 2. So for example, we could have 2 times 5 is 10, right? 5 is an integer. We could have 2 times negative 3 is negative 6. Again, negative 3 is an integer. We could have 2 times 0 is 0. Right? 0 is also an integer. Any integer, we multiply it by 2, we get an element of A. And we have a name for this set, right? This set is just the even integers. As another example, let's let B be the set of all numbers in the form n over 10, where n is a natural number. So we could have, say, 1 over 10, 7 over 10, 25 over 10. Any natural number over 10 is going to give us an element of the set B. Now, we're interested in the actual numbers, not in what they look like. So, for example, the number 3/5, if I multiply my numerator and denominator each by 2, which of course gives me an equivalent fraction, I get 6 over 10. And 6, of course, is a natural number. So, yes, 3/5 is an element of B, even though it doesn't look like it. Right? We can get a number that's equal to 3/5 by putting a natural number over 10. And so 3/5 is one of the numbers that's in B. Similarly, there are a bunch of integers in B. For example, we can take 10 over 10 equals 1 is in B. Or 50 over 10 equals 5 is in B. In fact, a little bit of messing around will show us that actually all of the natural numbers are in B. Right? Just take 10 times whatever number you want to get over 10 gives you that number. Here's one that's a little bit trickier, right? Our generic element now has 2 different variables in it. So let C be the set of fractions P over Q, where P is even and Q is odd. So even numerator, odd denominator. So we could say 2/3, 8/17, -6 31sts, right? There's no rule that we have to only have positive numerator and denominators here, right? So 2/3, 8/17, -6 31sts, anything with an even numerator and an odd denominator. Are there any integers in B? Well, yeah, let's just come up with an example. Let's see, 6/3, right? 6 is even, 3 is odd. That's equal to the integer 2 in C. Oops. These should both be talking about our current set C. So 6/3 is an element of the set C. Oh, you know what? The number 1 is odd. So if we take any integer, say, and write it over 1, we get an element of the set C. So I think we can get any even integer to be an element of the set C. I'm not sure if we can get odd integers to be in this set. I think only even integers are going to work out for us.